Today we will be covering Chapter 13, Rescue Belaying. Your objectives for Chapter 13 are to describe the purpose of rescue belays, identify and describe brake belays, discuss the tandem Prusik belay system, discuss the role of load-releasing hitches in rescue belays, and describe the use of the 540 rescue belay for rescue loads. You must consider what danger you are protecting against when belaying. Equipment used for recreational belaying may not be suitable for rescue loads. With rescue belays, you are usually protecting heavier loads of at least 600 pounds with relatively short fall potential on static or low stretch rope. Recreational belay devices are designed to catch lighter loads of about 180 pounds with potentially huge fall distances on dynamic rope. Your decision about how to belay should be based on your analysis of circumstances, including weight of load, maximum potential for fall distance, desired stopping distance, and maximum arrest force and other system factors. In the past, NFPA used to refer to loads as being one or two-person loads. It now refers to technical use and general use equipment. Each has different equipment performance requirements, but neither of which are dictated by the number of people on the end of the rope. When operating in a high-angle environment, the rescuer must use critical thinking to analyze the rescue system potential for failure. This is true for all rope rescue systems, and especially so in belay. Complete system failure refers to the system completely coming apart. Catastrophic failure refers to the result of the failure, whether that be injury or death. The critical point test can be applied to both equipment and team members. You must examine every element of the rope rescue system to locate any critical points. A critical point is one that, if it fails, will result in failure of the entire system. With a whistle test, try and imagine if a lightning strike struck the rescuers and everyone let go. Would the light load, such as a patient in a Stokes basket, still survive? This test examines whether the system will perform automatically should everyone let go. This would duplicate what would occur in a catastrophic event. It is also essential to consider how complex the system is. More redundancy does not necessarily mean more safety. As a system becomes more complex, its potential for failure increases. A variety of belay systems can be used for rescue loads, but each system has its disadvantages. Knowing the equipment and being proficient with the equipment available will help decide which belay device is best for the situation. Two commonly used braking devices are the brake bar rack and the brake tube. These two brake systems are designed so that each lowering device backs up the other. There are some advantages and disadvantages of brake belay devices. Some of the advantages are that they don't require special equipment solely for the belay. The role of the brakeman and the belayer require the same skill and can be interchanged easily. Also, brake belays do not usually accidentally engage and hang up. They do not require load-releasing hitches, they provide a soft catch, and are predictable in the way they perform. Some of the disadvantages to the brake belay is a reversibility. Reversibility can be difficult to change from a lowering system to a hauling system. If the operator is certain to involve only a straight lower, reversibility may not be of concern. The individual operating the belay must be well coordinated and alert for failure of the other system. A brake belay is often referred to as a conditional belay because it arrests the falling load only if the brake device is operated properly. The tandem Prusik belay is an inexpensive, commonly used belay system. It consists of two triple wrap Prusiks anchored securely and placed in line on a belay rope. If rigged correctly, it will exert a clutching action, otherwise known as friction, and grab the rope. Unlike a camming device that creates an abrupt shock load, the tandem Prusik belay stops the load gradually. There are certain conditions in which a tandem Prusik belay may not catch the falling load. For example, the equipment is icy or muddy, the Prusik cord is wrong diameter or material is used, or the hitches are not tied tightly enough. Let's talk about material and size briefly. The prusik cord should be 2/3 to 3/4 the diameter of the mainline rope. This usually works out to 8 mm prusik cord to be used on 11 mm rope, or 9 mm prusik cord for a 12.5 mm rope. The construction of the prusik is a compromise between two features. The softer braid cord grips better, but is more difficult to loosen, and harder braid cord is just the opposite. In high-impact situations, the tandem prusik belay can cause the belay line to fail by pinching it until the rope separates. The success of the tandem prusik belay very much depends on the interaction of the prusik cord material with the rope material. To make sure the system will work when needed, you should practice the prusik cord with the rope you will be using in a rescue situation. Operating the tandem prusik belay is easily practiced in non-emergency situations. It is important to do so because if they are not tied correctly and tended to correctly, they may not catch the falling load when needed, or the reverse may happen. They may catch when not needed and lock the system up. A properly constructed prusik belay system requires a means of releasing the prusik should they accidentally set and lock the system. There are several ways to release the load, and these techniques usually involve a load-releasing hitch. The radium load-releasing hitch allows the weight accidentally loaded on the belay line to be transferred back over to the main line. The load-releasing hitch described in this text is a radium release hitch and was chosen because it can withstand high shock loads and can lower the arrested load under control. Not all load-releasing hitches have a shock-absorbing capability. There are commercially made load-releasing straps that have very little, if any, shock-absorbing capability, but are easy to construct. The tandem prusik should be tended by a belayer wearing gloves. Before a raising or lowering operation, the belayer must make sure that the prusiks are tied correctly, the proper distance apart, and snug. To check for tightness, the belayer should listen for the sound caused by the rubbing of the sheath of the belay rope against the inside of the prusik as the rope slides through. This may be difficult to hear during an emergency, and again, practicing with the prusik belay before the emergency will allow the belayer to check for tightness based on experience and feel. If the prusik were to become loose at any time during the operation, the belayer must call stop immediately and halt the operation. The basic technique for prusik tending is to keep one hand cupped on the prusik as the rope is pulled in or let out. Use the other hand to take up or pull out the belay slack and to feel the tension so that you can decide if more or less rope is needed. The prusik mining pulley is sometimes used in raising operations to help operate the prusiks. The side plates are designed to keep the prusik knots sliding on the rope and to prevent them from binding in the pulley. When the tandem prusik is rigged correctly, they catch the edge of the pulley side plates and allows the main line to enter the pulley. The prusik mining pulley is designed in such a way that should failure occur, the tandem prusiks will grab the rope automatically if the rope should start to slip through them. The 540 rescue belay device works as an automatic belay for rescue loads. This means that it can safely arrest the load and lock itself onto the rope when necessary. As talked about earlier, a brake belay is just the opposite of the 540 belay and is a conditional belay because it arrests the falling load only if the brake device is operated properly. The 540 is an automatic belay. The 540 works better on new, clean rope. Old, dirty, fuzzy ropes can cause it to lock up frequently. Again, there are advantages and disadvantages of the 540 belay. Advantages of the 540 belay are that it allows directional loading, is self-locking, easily lets rope in and out when it is loaded. A disadvantage of the 540 is belay that it is specific to a narrow range of rope diameter and is heavy. It weighs approximately 1 pound 6 ounces. There are two models available, one for the 10.6 and 11.6 millimeter static rope, and one for 11.5 and 13 millimeter static rope. The design allows the device to operate properly when loaded with rope wrapped in either direction. The 540 belay meets the criteria of the belay competency drop test of the British Columbia of Technical Rescue. This means that it can catch a 3.3-foot drop of a 617-pound rescue-sized load onto 10 foot of 12.7 millimeter current rope within 3.3 foot of additional travel and with less than 15 kilonewtons of peak force. A built-in lever resets the locking mechanism to quickly release the arrested load, eliminating the need for a separate load-releasing hitch or device. To rig the 540 rescue belay, attach the 540 to the belay anchor system using a suitable carabiner. Keep all parts of the 540 rescue belay unimpeded by any obstruction or obstacles that could interfere with the proper belay technique, locking or releasing of the device, or releasing capabilities. Wear gloves and stay a significant distance from the device to keep your hands free of all moving parts. Always keep a firm grip on the running end of the belay rope. To prevent accidental rope locking while lowering or raising, feed the rope straight into the 540 rescue belay. This is especially true when using wet, dirty, muddy, fuzzy, or stiff rope. While lowering with the gloved hand, provide resistance to the standing part, that is the load side, and with the other hand simultaneously feed running end of the rope into the device. While raising, pull up on the standing part and feed it into the device and then pull on the running end. To lock off the belay, manually trigger the 540 rescue belay by firmly holding the running end of the rope and sharply tugging on the standing part. If the belay must be left unattended, the device must be locked off. The lock-off can be made more secure by tying the running end of the belay rope around the standing part with an overhand on a bite knot. The 540 rescue belay is not to be used as a general descent control device. If the 540 rescue belay receives a significant shock force, the rope in the device may stiffen while arresting the fall. If the belay rope is only lightly locked off, quickly reversing the direction of feed can return the pulley to its neutral and centered position. If this cannot be done, make sure the mainline rope is locked off, then use the release lever slowly to transfer tension back to the main line. Maintain a firm grip on the running end of the rope. If a significant shock force has occurred, it may be necessary to thread a piece of webbing temporarily through the top of the release lever to make the pulling easier, removing the webbing as soon as the load has been released. The multi-purpose device, otherwise known as the MPD, is a multi-use variable friction descent control device for rope rescue systems. It can be used to belay either lowering or raising system and can be switched from one to the other without changing hardware. The MPD has a high-efficiency pulley with an integral rope grab mechanism. The MPD is available in two designs. The 13 millimeter version is used for 12.5 to 13 millimeter rope, and the 11 millimeter model is designed for and tested with 11 millimeter rope. The next three slides contain Chapter 13 summary. Please take the moment to read the following slides as a review. Thank you and have a good day.